Hi, welcome back. Now there's a talk about continuous integration and what happened in the last 3 years.
Thanks. So I'm known as Mika, being an independent consultant, project lead of Grimmel.org, a Linux-based live system, Debian developer, and author of Jenkins Debian Glue, which is Debian packaging through Jenkins. Being from Graz in Austria, and I gave a talk about continuous integration in data centers 3 years ago at OSDC. So why I am here? I want to share my experience from the last few years, what went well, what didn't went so well. I don't want to repeat much of my talk from OSDC 3 years ago, but just so I have a feeling who is here. Is there anyone of you here who attended my talk 3 years ago? Okay. Who of you uses a continuous integration server, Jenkins, whatever? Okay, so 90% or even more. So what are we looking at today? What do we actually want to achieve? What challenges do we have? How did we get there? Talking about code review, which is an important part of what I'm talking about today. Give some hints about testing tools, which are very useful. Some words about Docker. Infrastructure tooling. Some anti-patterns you should be aware of, and some pain points which are kind of unsolved or, yeah. So what are we actually interested in? Our expectations are that we have some independence, so we don't want to be or depend on some external service which is down, and we can build our own system, be able to scale in terms of people, like the team might grow, or the projects might grow, the systems might grow, new servers, whatever. Reliability, we want to have some trust in our own systems. Also, of course, performance. Performance should be better and not getting worse. Reproducibility, so whatever we build should be able to rebuild again and have the same result. Of course, related to predictability. So how fast can we get the result? What will we get? And traceability from the origin, like new feature or a bug report, until we ship it to the customer or in the data center or wherever. And we shouldn't forget about innovation. We don't want to just add new tools to our stack, but we also want to have the flexibility and be innovative without having some kind of don't touch the running system. So from the well-known continuous delivery book, this is what a deployment pipeline should look like. We have some delivery team which provides some code change. We have version control, which gets then to build and unit tests, and if something is broken, reject, start again. And only if all the steps through a pipeline pass, we actually ship it to the customer, to the actual production system, whatever. So this is what we are interested in. There are some challenges. For customers, I'm doing consultancy for, we got, for example, more employees, so the team grew. We have more remote workers where you're not sitting in the same office as the other folks. More customers, like the customers themselves got more customers, and they got more projects, like in terms of new software repositories, also in terms of projects with clients. So how did we get there? There's some important, like, technical depth stuff. If you're just doing emergency-driven development, you can't actually invest in your infrastructure, in your tooling. So it's kind of important to know where you should actually focus on, and I like those two quotes. You have to improve, and we got like better documentation, better communication, more tests, more testing tools. And also a faster release cycle. So when we started, our release process was kind of manual and do all kinds of magic and go through checklists. And nowadays, we reached a point where we have a one-click release. It's like press one button and there's a new hotfix, there's a new release. So everything automated. So what we can actually do with all of this is also the speed of delivering changes got much better. So pipeline we use nowadays looks like this. We have some development, some testing. You do a Git commit, send in the change for review, and Jenkins then verifies the result. It gives a +1 if everything is fine, -1 there's something broken, please look at it. Only if Jenkins verify happened, you integrate the code reviews, or usually only then you integrate the code reviews. So first of all, it's a technical review in terms of automation, and then it's a human review. We automatically provide Debian builds based on every review, so you always have according Debian packages, which can be used for testing, for giving it a deeper look at it. And only if everything passes, like code reviewers are happy, Jenkins is happy, we submit the actual results to the master branch or whatever is the production branch. We have some internal tooling where we can roll it out, the Debian package to Puppet or whatever is in use. And of course, there's the other side, not just internal tooling, but also customer view, like you ship it in a product and only then gets available to the customers. So very important part, which we integrated in the last 3 years, is code review. There are plenty of code review systems available. The main open source ones are they mentioned, Gerrit, GitLab, Fabricator, and Review-Board. We went for Gerrit, mainly because it has good Jenkins support. It plays well together with Gitolite, the Git server in use at my customers. And there are plenty of advantages of code review. Like you start to share your knowledge. You have to talk about your code. Someone else has to review it. You can even integrate people not being aware of the details of the code. They start to learn something. So you get really a better knowledge within the company. Improved maintainability, of course, is one of the reasons why you actually focus on code review. Also better code, because someone else has to understand the code or wants to understand the code. Maybe the logic isn't written in the best way it could be. And there's some kind of broadcast progress within the company. Other folks in the company are aware of what's being worked on. Otherwise, they are just ticket and this is solved. Nobody knows, is someone working on it already? How long is it taking? What are the problems? Most of this is being visible once you have code review and just look at the changes that are flowing in. And there's some like communal ownership. So everyone in the company could just explore changes in a different project and get involved in it. So it's not just a technical change you get with code review, but it's mainly about social changes and human interaction, which is very good. For the ones of you who don't know what Gerrit looks like, it's kind of a web interface thingy. This is the OpenStack Gerrit installation. Then you have just a short demo is like if you make a change in the version control, you just commit it, and there's a tool called Git review, and that's the only thing you have to do then actually. There's a Gerrit file next to the Git configuration repository, and then you send it in for review. That's it. Then it's available on Gerrit. There's nothing more to do. You don't have to use a web interface to submit a new change or whatever. It's available at the Gerrit installation then, and people start to look at it, of course, together with Jenkins. So Jenkins starts with a verification process where plenty of tests run. People can comment on it. I would prefer that you didn't match this. I think this is okay, but my concern, blah, blah, blah. So we discuss this change then. And only if a core submitter who are able to set out +2 or also reject the code, only then is the actual decision about the change. So there's a web interface. Not everyone is happy with web interfaces. You can, of course, download the change for reviewing locally on your system through git review. There's a -d flag, which just provides the change set ID. And then you have it available offline for review with git diff, git show, can run it locally, whatever. If you want to make any change, you can just modify it as long as the change ID in the commit message stays the same and you send it through git review. There's just a new patch set to the same change. So that's the iteration you go through. And for the ones of you who use Gerrit and actually don't like the web interface at all, from the OpenStack project, there's a tool called Gerrit, which is a command line interface to Gerrit, which also has offline support. So you might just be in a train, in the airplane, or a lonely island with your gin tonic and the laptop and be done. It's offline capable, so you can do all the changes, add commands or set +1, whatever. And once you're online, it sends all the data back to the Gerrit server. So this is really nice. What's important if you want to start with code review, no matter which code review system you're using, there are some important parts you should be aware of. There should be some kind of meaningful response cycle. It doesn't mean it needs to be fast at all times, but it shouldn't be like you send in a review and 1 week later you get a review and I'm not happy with this, you change it 2 weeks later. So there should be some kind of, this should fit your company development cycle. You should be friendly. Even if you don't like the code, don't make it personal. It should be like, be friendly to the one who are talking to. It's really like the social stuff is important about it. And very, very important, include and integrate newbies, new employees, people who want to get involved. Because starting with this, people actually can dig into your code base and maybe also help you in the future. But it's also about getting them on board with all the knowledge within the company. This is kind of an important process where I'm talking about the Puppet stuff later on. Best practices. Keep reviews as small as feasible. This also makes testing easier, so you don't have like a large blob put in, nobody wants to review. Make it as small as feasible. One feature, one commit, one review. Use code review also for your infrastructure changes. So the infrastructure as code went through the community a few years ago. And this is kind of important. Whenever you do a change for your infrastructure with Puppet, Chef, Ansible, whatever, use it in code review. It just integrates other folks, what changes on your infrastructure are coming up. It's also about the interaction. No direct pushes to production branch. So you can just forbid this on your Git, Subversion, whatever server. Make it testable before with Jenkins, with all your pipeline stuff. And only if it passes the QA of your CI server and the human review, only then put it into production. This also means that the master or production branch, or however you name it, is deployable at any time. So you just avoid this kind of feature branches. Nobody knows which one is the one I'm actually interested in using in production. So really, no direct pushes to production branch. You want to be able to trace all these infrastructure changes. So what's important is like that you have some kind of mapping, no matter whether you're using branches or tags for actual production usage. Map them to the environment, for the Puppet environment or for your release, and to have some kind of understanding. If I do a vagrant up, whatever, this should quite match what I'm expecting. Like if I'm doing some work on a development branch, it's like the Vagrant app development, then this should be the result of it, so that you have some kind of understanding what I'm getting here. What's very useful for us, or turned out to be useful for us, is a direct connection between reviews and bug tracker, or issue tracker, however you call it in your company. So we put in every single commit message at the start of the first line ID, which is like for a bug tracker abbreviation, and then the according bug tracker number. And this directly pinpoints to the bug tracker then. And in Gerrit, for example, you can configure the pattern, how it should look like, and it gets a click then. So if you have some details in the commit message and it's still not clear for the reviewer what's going on there, it's just a click away, go into the bug tracker and read on all the customer bug reports or whatever has been connected to this issue, and gives all the details. It's a small change which quite modifies the workflow. There are some challenges with implementing code review in your company. Different time zones are definitely a problem, like sitting in Germany and other developers in the US or in Asia. Kind of difficult, needs some adjustments depending on how the time zones are actually used. In your company, like when do you start to work? There's a new workflow that you need to be aware of. When having no code review, there's like just push in the stuff. With code review, this kind of changes, and people need to get started to this new workflow. Refactorings are quite difficult because refactorings aren't just a small, tiny change usually, but it's like you're restructuring the project or plenty of functions. So this is definitely a difficult topic. There are some added delays. It's like emergency fix you usually would just push out. Now gets a delay waiting for someone else to review. Usually it's quite good because, I mean, 4 eyes see just more than 2 eyes, and plenty of disasters are usually happen just because you overlook stuff that would have been obvious to someone else. And there's some culture change. So in the company, there needs to be support for this. You can't just integrate code review in your pipeline and everybody will be happy. So this is kind of a learning process. There are some dangers even. You have a very, very large change, which is like you're modifying tens of files, and the reviewer says, whatever, +2. I'm fine with whatever is there. It's very hard to review. I don't care too much. And then you have this kind of tiny changes where you're just modifying a error message or whatever, and this turns up as a like 20 comments dialog. Couldn't you modify the wording for this? I would like to have this variable quoted or not quoted, or the logic could be simplified then, and you're spending like 3 or 4 hours of developer time to just have something that's actually not worth discussing. So this is a phenomenon you should be aware of and actually work against. And we have another situation you should be aware of, and this requires some team culture. So what's standing there for the ones who can read it from the back? No need to double check this change list. If some problems remain, the reviewer will catch it, and the reviewer actually thinks no need to look at this change list too closely. I'm sure the author knows what he's doing. So it's kind of you're not entirely sure if the other one actually does that change. You should be using this in kind of a team culture thing. I wrote just some resources which are interesting papers on code review that might be worth looking. The slides will be available for you. Now for testing tools that we or integrated or are still using nowadays, that might be worth a closer look. To just start with the testing pyramid, which is very important to be aware of. The most important stuff you should focus on are fast tests which are usually unit tests. We are just testing small changes, features on a source code base. We have integration tests where you then see whether all the components within your projects play together, and then you have the system test where you actually test your project against different projects, all the integration parts. And what usually happens is, if you're starting with testing or getting more into tests, is starting with the system tests. And those are the ones that should be like 5% or a max of 10% of your project, because they are expensive to develop, very expensive to run. They consume lots of time, so you can't actually run them, usually don't run them within your pipeline automatically. Like what you want to do is, say, Git review and get a feedback from Jenkins to Gerrit, get a report back, and it should be done in less than 5 minutes. Otherwise, people will start to complain, and I don't care about this. So these are the unit tests, the fast ones. That's where you should focus on, and this is important to get right. And usually you see the opposite side of the pyramid, where you have plenty of system tests, a few integration tests, and close to none unit tests. And this is hard to maintain. You have plenty of problems there in all kinds of things. So a tool we very much like is Goss. It's written in Golang, and is very useful for some very simple validations. If the output can be used in Jenkins with JUnit and tab output, RSpecish and Nagios, and JSON output is available too, so you can even integrate it in your monitoring system. And what's nice about Goss is it's very small, simple, and one binary. So you don't have a ton of complex frameworks and many layers where something might go wrong. It's really a simple tool. There are some resources like address, is this a reachable command? I just want to compare the exit status and also its output to what I'm expecting. So this is very useful. You just write your script, do whatever magic you want, send the according exit code and maybe an output on standard out, standard error, and just compare it with the result. And these are the resources that are available out of the box. And just some short demo. So what I'm doing here is I have nothing, really nothing. I have no configuration at all. I just say Goss auto add SSH, and Goss looks at my system and says, well, you have SSH with group ID 103, you have a package installed in this version, you have a running process SSH, and SSH is enabled and also running. So this automatically generates this configuration in the Goss YAML file. This looks like that. Whatever you want to keep it then. And of course, you can modify it manually or with further commands. But that's it. There's YAML and JSON configuration format supported. And then you run Goss validate the actual file. And this took like way less than the second. We have plenty of tests in setups, and running like 200 tests takes like 2 seconds or something like that. And as a further demo, I want to add port 22 as a check, so it listens on all IPs, and listening through is also enabled. So I validate against. Now instead of 7 tests, I have 9 tests, and now I just, for a demonstration, modify the port number on port, instead of port 22, I use 23, rerun again, and it says with the output tab that so can be used for Jenkins integration, same for JUnit, but it's not so nice for presentation. Those failed. I have nothing listening on port 23, and IP doesn't match there either. So very, very simple to use. It has very low entrance effort, so you can just start using it. It's really a no-brainer. For very complex tests or system tests, the framework I very much like is PyTest. Just as a disclaimer, while it's Python, you don't have to use Python at all. We use it for system testing of completely unrelated to Python projects. So while you, of course, can use it in your Python projects, and I absolutely recommend that. You can also use it for non-Python projects. And a Debian developer wrote a very nice system test integration for his LLDPD project. Also has some nice slides available where he does in namespaces for networking, really fancy stuff. And I can just recommend to use it. It has nice JUnit and tab output as well, so integration in your CI system should be a no-brainer. Supports fixtures, scopes, monkey batching, so you can actually fake whatever you want and get very nice things up and running. We also noticed a few broken package dependencies in our system, where we have packages which depend on specific hardware, or can be installed only on very, very specific systems. And those are usually not very well tested then, because the testing is much harder then. And those packages have broken dependencies, and this check project provides 3 tools, which are those step check for Debian packages, RPM check for RPM packages, and Eclipse check for OSGI plugins. And they actually check that you can satisfy all the dependencies and the conflicts of the package pool you have. Like, this is my Debian repository or my RPM repository, and it checks that all the packages could be installed with the available set of packages. Very fast. It's kind of a complicated problem to actually solve that, but it's a nice set solver for usage available open source. We also went into Puppet testing. There we have Puppet linked, which is like the style guide check, which sadly not yet really supports Puppet for specific code. We have RSpec Puppet and Pika, but I don't want to focus on this because David Schmidt will give a talk about this tomorrow. So if you're interested in Puppet testing, you should absolutely go to David's talk tomorrow, Introduction to Testing Puppet Modules. There are some rules for the tests and infrastructure. You should test really everything as soon as possible. You should avoid that trap we ran into. Like, we had a project with a test suite. The test suite actually verified that everything works fine, but we didn't integrate, for whatever reason, the test suite into our CI server, so it wasn't automatically executed, just manually, if you remember that there is a test suite. So the project grew and grew and grew, new features were added, and like, we had reached a complexity of the project that we didn't want to add any new features without testing. So we said, well, let's look at a test suite. And we actually noticed we can't even support the test suite with the project now anymore in that way, because we had new features in the project that prevented us from using a test suite because it requires root permissions at a specific place, so we can't just run the test suite anymore. So it's really important to start as soon as possible with it and actually use the tests in your CI server. You can then really avoid problems doing commit or push time, depending on your actual setup. And don't rely on historic knowledge in your company. Like, this is the employee who knows what's going on and why we have this kind of hack there. As soon as you start with testing and you verify these results, you can actually refactor the code without breaking it in production. And new employees will really have a hard time just looking at the code with historic data without any tests, without any details. We have also started, or actually kind of finished, to have test systems to work on infrastructure changes without breaking anything in production, which is really tricky if you want to modify anything and you're not 100% sure will this break our production system. So you should really have test systems available for whatever you do, and for whatever should be really everything. It's like, you have your production system and you have a clone of your production system for testing internally, but what you might not have is like the Jenkins environment or the code review system? What about changing something in the code review system or in a Jenkins setup? So you modify anything and you can't release anymore because your build infrastructure is broken then. So you should have test infrastructure really, really for everything. I just wrote down a few resources which are interesting. Advanced Testing with Go is from HashiCorp. Interesting slide set where they explain how they test complex stuff also. System testing with PyTest and DockerPy is an interesting approach just for some brainstorming. And the book, How Google Tests Software, is also some kind of get some ideas how other companies do this. So, some words about Docker. Of course, I'll start with an obligatory Docker slide. This is kind of too true, sadly. It's a moving target, Docker, moving very, very fast. And this is actually what I can just sign. Docker doesn't solve plenty of problems. Just see the right side of the picture. So, what containers actually kind of solve, or what Docker solves, is this kind of dev side, but the production side is completely unsolved, or doesn't automatically solve your problem. Like, I need monitoring, I need security support. So this is kind of the from my point of view, still open discussion, like distribution packages and configuration management. This is not what I want to talk about. This is like a completely different talk then. But I want to talk about what Docker solved for us. And we had a few use cases that we can actually solve nice with Docker. So where I see Docker is like the Vagrant of containers. Like Vagrant provides a very clear understanding and workflow of what you should do and what you can do. And with Docker we have a kind of independent solution. No matter whether you're on Linux or Mac or Windows, you have the same interfaces available. We managed to solve a problem which hit us for way too long. We can share the environment between developers and testing infrastructure. We had like a Selenium server for automated web tests, and if something broke there and Jenkins said, well, there's a test failing, developers weren't able to reproduce it because it worked for them locally. Now what they can do is run Docker pull, get exactly the copy of the Selenium environment and reproduce the running tests locally. And this is really, really useful. And of course you can do like with full VMs and whatever, sure, but we need very fast test cycles to integrate this kind of tests in the Gerrit Jenkins pipeline. So what we are interested in is not wasting any time with automated VM setup or whatever. Docker run, focus on the tests, and we have a clear interface or API we can focus on. Of course, we started looking at LXC, and there are plenty of projects now which might be worth looking again. But Docker actually solved this interface problem for us, that we can actually just run it and not having to script many layers. How do I connect two containers together, networking stuff, inspect them, and all this kind of stuff. So they solved it for us, and developers are now actually able to control the test environment themselves because they make the changes in the code review system for the Docker containers, for the Docker images. So they can help us run the infrastructure we use for testing. We use Docker just for testing. We don't have it for any, like, what we would call production system, like a service. We just have it for testing, and this kind of works well. We started with the Docker registry, which was the name of the original project. Nowadays it's called Docker distribution, and this is an implementation of the Docker registry for Docker versions from 1.6 and newer. It's very fast moving. It kind of works for us, and we just have our local registry without depending on any foreign service. There's a workflow problem which is really tricky. For every project that ships a Docker file, Jenkins can identify this in our setup and builds the according Docker images for us. This kind of works, but what's really, really tricky, and this is a kind of still in progress, all the life cycle of such an image. So what to do if there's a bug in OpenSSL and you want this fixed? How do you actually manage to update all the according images? What about the result then? You modify the underlying image, break tests. How do you proceed with this? So this is kind of the right part of this picture I just showed with unsolved problems. And image lifecycle is really a tricky point you should be aware of when introducing new underlying systems in your infrastructure, like Docker. That's about Docker. Infrastructure tooling, we in the environment I'm mostly talking about, we also had Puppet 3 years ago, and the code base is nowadays something like 6 years old. We had our own wrapper for Puppet environment, so you can just test your stuff without breaking production. We moved to R10K, which kind of works as we need it. Hira still there. PuppetDB, and what's new and what I really like as an addition to it is Ansible, because we can actually query PuppetDB and run ad hoc tasks in Ansible with code review. Because, I mean, we also have mcollective, but what we usually don't have when using mcollective is actual configurations for what are you going to do. And with Ansible, we just query the PuppetDB for the hosts we are interested in and to run the commands, and then can come up with an Ansible playbook. That's the change I want to actually run. And Ansible doesn't replace Puppet for us, because Puppet is the configuration management part, and the Ansible is, from my point of view, more a deployment tool and ad hoc SSH solution, which works perfectly fine, but it doesn't replace Puppet for us. We had the Puppet code base sitting on 2.7. Nowadays we are kind of bleeding edge. The upgrade from the code base worked quite well. We expected way more headaches. We used the old Puppet dashboard, and nowadays use just the Puppet board, which also has kind of new features. And 6 years ago we started with writing our own Puppet code, usually or mainly because there were no existing modules solving our problems. Nowadays, the landscape has totally changed. There are plenty of very well-maintained Puppet modules, so we moved plenty of our stuff out of our code base and just use what's on Puppet Forge, all of the famous modules. And this is like just an advertisement that you should actually look at your own setup, and maybe you could just get rid of maintaining your own stuff. The important topic is also monitoring. It's very, very annoying if you have long-running tests and they fail with out of disk space, and you just have to rerun those 15 hours once again. So what you should actually take care of is automatic cleanups to get rid of old artifacts, caches, so you don't just have old data around without any actual usage. And use appropriate monitoring. And monitoring is important, not just for like being aware of low disk space on your test machines and whatever, but also for metrics. So you actually know what's taking very long in your pipeline, where you're wasting time, maybe because of some software is trying to reach an outer service which isn't available right now. And there are plenty of solutions. I don't want to get into too much detail about them, but Elasticsearch, Logstash, Kibana Stack, Graylog, InfluxDB, Grafana, all of them, plenty of nice solutions. But you should really start using something like that if you don't have it yet, because you have some actual data there which verifies that, well, this is the part where we actually waste most of our time. Monitoring software, this is just what we are actually using. There are, of course, other systems as well. I don't want to have a too strong opinion on this. CheckMK works very well for us for systems where we just want auto-discovery without too much overhead with configuration management and all this kind of stuff. For bigger setups, we very much like Isinga 2 with Puppet Isinga 2, so you don't have to actually do much of manual text configuration, but really start using monitoring for your continuous delivery setup if you don't do already. What we also have nowadays is, instead of the VV stuff we used 3 years ago, or which was available back then, and was replaced by Pekka from HashiCorp, and this is nice. It's nicely playing together with Vagrant. So what we do is we have Grimaldi Bootstrap, so we can build our own Debian-based base boxes where you can then just put your stuff into them as you want it, and Pekka automates all of this process. So with the combination of Grimaldi Bootstrap, Pekka, and Vagrant, we just have nicely working Vagrant images. Of course, depends on your actual environment, what you want to do. But Pekka and Vagrant is a really nice combination. And as I was notified today, Pekka is also available in Debian Unstable as of today. So we also invested into disaster recovery. What we do nowadays is a daily fresh installation of the nodes, and daily fresh installation of the actual production nodes, in terms of they should look like the production node. So whenever something really crashes in the data center, we should be able to rebuild all of them from scratch. We do this from Jenkins. We have some kind of fake data for Hira. But what we do is we have some kind of fancy USB pen drive with all the sensitive data on it from Hira. And what's nice, this can be anywhere around the office, so just someone has to make the actual sync who has access to it. But as soon as you type the wrong pin 10 times, it just automatically deploys itself. So one copy in a safe, one copy can just lay around. And what we do there is, or to use that, is just Pixie Boot with iPixie. It's very, very nice to just script all of your magic you need. So with templates, you can automatically generate the according scripts. We use Grimmer ISO in this case because I know how to use it as a Grimmer developer. There's a NetScript option, which is kind of nice because you just boot the ISO, and in NetScript you can just provide a URL to some script. It's getting automatically fetched and executed, so you can control whatever you want. And you can, of course, then do magic like, depending on the MAC address of the system or on RAM or whatever, fetch the according file. And in this according script behind the NetScript boot option, we actually deploy the system, again, through Grimaldi Bootstrap or whatever you want to do, of course. And what might be worth mentioning is NetBoot XYZ. It's a nice project based on iPixie, where you have plenty of templates available for booting Debian, CentOS, or whatever through the network without having the need for having the according ISO files locally. So this is easy to get started and actually identify what do you want to use in production. I just want to focus on some anti-patterns. I already mentioned this 3 years ago, and I need to repeat this all the times. Don't use SSH for fixing problems. There should be some kind of debugging interface. People not having access to the actual production system can just log in through SSH and fix problem. So you shouldn't have to call at 3 in the night the on-call engineer, but instead there should be some kind of layer, rundeck or whatever, where you can modify the system state and fix the problem for you. Flaky tests are horrible, so if you don't actually can rely on the test results, you just stop looking at the test results. So it's like, what's flaky tests? It's like you develop all the kind of tests on very fast hardware, and then you move to the actual testing system, and this is some old server in the back there, and it's slow, and it starts to run into timeouts and all this kind of stuff. You maybe have some sleep statements in your code base, waiting for some resource. Don't do that. So as soon as you have some flaky tests which aren't stable, people just don't trust and care any longer. Don't solve problems through cron jobs. Don't pull and pull. Trigger all the kind of action. Whatever you want to do, don't wait for them, but let you get triggered from the actual resource you're waiting for, to avoid too much overload. Manually setting up machines. I like to mention this, the snowflake pattern. They all look alike, but they are still different. So really you should have some automated procedure to automatically install testing system, production systems. They should be all automated, and we have plenty of tools available to solve this kind of stuff. Don't use checklists. I mean, there are some specific areas where checklists are useful, but try to avoid them by automation. Most things are on checklists just because you didn't do the actual automation yet. Plenty of stuff that can be found on checklists could be just automatically be done through a Jenkins job, Rundeck, or whatever. So really try to get rid of them. And don't make your business depend on others. I'm not sure how many of you are aware of the NPM disaster, where the left pad module was removed from NPM and tons of projects were failing. So what we have a policy, like whatever we introduce in company or companies, there must be a local mirror for it. No matter whether we are talking about Puppet Labs repo or some Debian mirror or a RubyGem, NPM, whatever. There must be a local mirror, so we have to be 100% independent from any foreign service. Also very painful is like if you have tools without any standardized output, so you can't actually really parse them. So if you write a new tool and generate output, please make sure it's easy to parse and you have a stable format. Usually you want to have tab or JUnit output for Jenkins integration and really use that output for your integration in your CI environment. Don't rebuild stuff just because you can. If you have a pipeline starting with one job and you have downstream jobs which are following through the pipeline, don't rebuild the same thing twice. Share the artifact you generate, the build result, share it within the jobs, just pass it through the pipeline. That's the idea of it, but don't rebuild it. Successfully preventing configurability, yeah, kind of like you start to have hard-coded IP addresses, host names, port numbers, some sleep statements, like checks, this is the test system, this is the production system. Make it configurable. There are plenty of formats available for configuration formats. Use them. How to get people to stare at Jenkins web. The Jenkins UI shouldn't be used at all, to be honest. Developers shouldn't have to wait for something or poll for the actual data they're interested in. If they make a code review change, some notification mechanism will be available for use. Is it mail, Java, Slack, or whatever? Use the according information. Once the result is there, notify them. But don't make your developers look at Jenkins web. And there's really no excuse for writing unit tests. There are plenty of software projects which have test suites solving really complex problems. Starting with that might be hard, but really there's no excuse to not writing unit tests. So some words about pain points. There were some kind of misunderstandings as we noticed. In Gerrit, I don't want to go into much detail there, but -1, -2, +1, +1, it doesn't sum up. So if someone gives +1 and someone else gives +2, it's not 3. Also there's a difference of usage, like some people actually give +2 while they mean +1 while they mean +2 because they want to have feedback from someone else and leave them for the actual +2. This should be something where you clarify this within your team or within your company, how you actually use this, and just fix it through documentation so it's clear for everyone how to use it. Cultural differences. There's a nice team handbook available from GitLab. They are a remote working company, and this is a nice example for a handbook how to actually solve problems in your company, depending on cultural background and stuff like that. Kind of important, it's social aspect. Some Debian-related pain points we experienced. Our release cycle went much smaller, so this one button release option turned up to be a problem for us because the mirror is moving so fast that whenever you run apt-get update within one test, you always get this hash sum mismatch error because you fetch two files and they are not atomar. There's a fix by Colin Watson enabled for Ubuntu 16.04, and we are looking forward to see this in Debian and all the related tools. It's fixed through a so-called by hash feature, if you're interested in looking into this. We also had some kind of pre-depends for the ones of you who know this kind of stuff. Might be aware. For the other ones, pre-depends is like my package depends on another one already being set up, and avoid it as much as possible. We had plenty of problems with automated upgrades and also with Puperts, our Debian tool for automated installation, removal, upgrade tests. The more sophisticated the systems become, as we noticed, the closer the toolchain actually needs stuff Debian already has or uses. So sometimes you say, well, why is this complex project in Debian in use at all? And once your project is growing and your infrastructure is getting better and better and more complex and more automated, you start to notice why they are Britney, DEC, Puperts, knows all this kind of stuff. Also, like mass changes, with plenty, if you build a new release, plenty of projects, depending on customer, 50, 100, 150 jobs are starting to hit Jenkins, and then plenty of jobs are following. And the actual repository hitting the data had blocking problems because it was just getting stuff. So this was kind of workaround through a wrapper from us, but actually it would have been nice to have a REST API with a scheduler, so kind of worth looking at different solutions. Jenkins related, structuring of hundreds or thousands of Jenkins jobs in Jenkins Job Builder. This is the tool from OpenStack we use for actually configuring Jenkins job. We don't want to use this in clicky web. Isn't easy, especially the more exceptions you have. So this is something really worth looking into. How can I actually structure my configuration management for Jenkins? Unreliable tests. If you start adding new tests in your pipeline, the question is, how do you handle errors? Maybe you have some old branches where you don't care about the tests. How do you handle them? So what we decided to use is whitelists or blacklists to reach 100% coverage over time. So we knew those three projects are fine. Let's just whitelist them, and all the rest is in a blacklist. So we just ignore the results, and every single new project which we consider as stable and the tests are reliable just go into the whitelist. Matrix jobs in Jenkins are not always fun. If you can just use simple plain freestyle Jenkins jobs, this is also true for very specific plugins in Jenkins. Don't use too much details of Jenkins. Sometimes it's just easier to write your own script. Also, availability of Jenkins is kind of important because, or your CI server, whatever it is, as soon as you have some maintenance window, you can't actually release right now. What happens if you upgrade your environment and it doesn't come back? What helped us is the lenient shutdown. For the ones of you who know this upstream and downstreams connections of jobs, you start a job, and what lenient shutdown actually provides is it finishes until all the downstream jobs are actually finished, and not preventing your Jenkins server to not getting restarted because there are stuck jobs in it. Also Zool and Gearman, which kind of move the data from Jenkins to a foreign system, an OpenStack environment, is a good project to look at. And Jenkins 2 provides this new pipeline concept now officially, where you can actually restart Jenkins master without having Jenkins slaves and jobs disappear. You should have maintenance windows and downtimes to actually identify problems you might have in your infrastructure. It's kind of use it to your advantage. If you have a maintenance window for your infrastructure, look at what problem can't you actually solve right now because some service is done. So last few slides, I'm aware of the timing. Some architecture decisions are visible only after surviving a new release. In our situation, this is like from Debian VC to Chassis. Is your system structured in a way that you can actually support a new release or additional distribution or a different operating system? So this is kind of something to keep in mind if you do some system design in your CI environment. Separation is very important. We have so-called full-featured PPAs, personal package archives, like Ubuntu provides. We have them through Gerrit, Jenkins, and Jenkins Debian Glue ourselves. And what we do is like through Gerrit topics, for the ones of you who know this concept, it's like you connect different reviews together through topics. We provide the according results in the same repo. This is something to keep in mind. It should be you should be able to test multiple reviews together in combination and have a specific result. And what was a good investment is like we moved release-specific settings into release-specific configuration and scripts. So if you have a maintenance branch, maybe do the configuration also in the maintenance branch, so you don't have to support in master all the old configurations and the code just adds up and never gets less. So takeaways from my side is automation is essential. Configuration management is something I hopefully don't have to mention nowadays anymore. You want some traceability in all your continuous delivery environment. Use code review. It's really one of the biggest changes I saw throughout the last few years, which really improves infrastructure and communication and human interaction. Use tests and testing. Usually it's really easy to get started, and once you're there and see the benefits of it, you can just continue. Communication is important. Talk to other folks in the company so you have not your own part nobody else can use, and try to bring dev and ops together, no matter how you call it. So, are there any questions left? I'm aware that 88 slides within less than 1 hour are kind of a challenge. So if there are no questions, I should be here around anyway, so you can fine with just catching up with me. So, thanks.